Okay, so common factoring is when you take the greatest common factor out of the terms in the equation. So think of this almost as two separate ones. We'll deal with the top and then we'll do with the bottom. We'll take a common factor from both. So first of all, a common factor of 12 and 6 is 6. So I could take 6 out. And I can also take n out, you're right. So I can take 6n out of both of them. Okay, so we take 6n out and we're left with 2n minus 3m, right? Same idea.
Isn't it 1? Because you took 6 out.
Oh, sorry, you're right. M. 6 divided by 6 is 1. You can just leave it as m. Same idea in the other one. The only difference is we'll take 4m out of this one. So we take 4m out, we're left with 2m.
Isn't it 1?
Oh, jeez. Until I had a long day. 1m and minus 2n. Okay. Now, if you take a look at these here, they're almost the same, but this one here is a negative m and positive, and this is negative and positive. So what I can do is I can take a negative out of either of these. Okay? Think of negative 1 as being a common factor also. So let's say I take negative 1 out of the, let's just do the bottom one, okay? So our top's still the same. If I take negative 1 out, I'd have to multiply negative 1 times the common factor already on the outside. So I'd have negative 4m. Does that make sense? On the outside? And I'm going to have negative m plus 2n. Now this is just a rearranged version of that. So we'll rearrange it so you can see. We get 6n, 2n minus m, divided by 4n, and then 2n minus m. Once we do that, because this is multiplication, okay, we can just cancel any common things out. So this bracket and this bracket cancel out because they're going to end up with the same. So we'll end up with 6n over 4, negative 4. So essentially it's negative 6n over 4m is our answer. Okay, so 25e. When you're doing fractions, the main thing you got to remember is specifically if it's an adding or subtraction question, your denominators have to be the same. Okay? So if you have a multiplication or division question, it doesn't matter. You just start multiplying numbers, and you know the division rule, you just flip the second fraction. Yeah, so just start multiplying across. It's pretty straightforward. It might get complicated with the amount of numbers you have to multiply, but there's really no changing of the numbers. When you add or subtract, you have to change the numbers. So right now we have two different denominators. So I have to find a common denominator. Now luckily these are just whole numbers. There's not much else to them. So a common denominator between 5 and 4. Do you know one?
20.
Yeah, 20. So in other words, I have to, what do I multiply 5 by to get to 20?
4.
Yeah. So I have to multiply bottom times 4 and the top. Okay? Same idea here. I obviously have to do that by 5. So I got to multiply the bottom and the top by 5. So our next line, when I multiply this by 4, I'll do it in just in red so you know what I'm doing. So I'm multiplying that by 4, right? So our bottom becomes 20, and our other bottom is going to become 20. 4 times 4x is going to be
16.
And 4 times 1. Okay, so we have that. And in our other one, we had to multiply the top and the bottom by 5, right? So I'm multiplying this by 5. We're going to be left with
10x minus 5.
Yeah, that's right. Okay. So once we have a common denominator, we can just turn it into one fraction. Okay, so I'm going to put these two into brackets. So I have 16x plus 4. I'm going to bring up the addition sign, plus 10x minus 5. And this is all over 20. Okay? Think of it like that. Well, now that we do that, I just have to add our tops. So, because this is an addition sign, I can just drop the brackets. So I get 16x plus 4 plus 10x minus 5 divided by 12. I'm going to collect my like terms. So 16x plus 10x, what's that going to give us?
26.
Yeah, so I have 26x. And 4 minus 5,
Minus.
I have 1 over 12. Okay. And that's as simplified as you get. There's no restriction because it's divided by 12. Does that make sense?
Mm-hmm.
Okay. In this question, again, we have a negative sign, so we have to get a common denominator. Now, this one is a little less straightforward. From looking at these two, I really don't know what I have to multiply either of these by to make both numbers or equations on the bottom the same. So what I'm going to do is I'm actually going to do the reverse. You're going to factor them first. Okay? Is that what you did when you first started it?
Yeah.
Yeah. So I'm going to factor them first. And did you factor it on your question?
I got x plus 2. No, yeah.
2 plus 2, 2 plus 1? Okay. And in the other one, did you get t plus 2, t minus 1?
I did opposite.
Ah, okay. When you factor this one, I've shown you the way I do the factoring, right? Where we take the first terms.
Yeah.
And last
And they're
terms.
making us do that now for.
Are they? Yeah.
So.
This is a fast way factor. So obviously these are the only factors of the two. So I know I'm going to have 2 and 1, but it's got to add up to our middle one. So it's got to be positive 1. In order for this to be positive 1, that means this has to be positive 2, and this is going to have to be negative 1. So my 2 will have to be positive, and my 1 will have to be negative. So when I go to put it in the brackets, I have t plus 2 and t minus 1. That might be why you didn't get the correct answer. The factoring part's pretty important.
Mm-hmm.
What you can see now is, okay, well, we know this and this are the same. The only difference is this, t plus 1, t minus 1 are different. So in order to make the bottoms the same, I'm going to multiply each bottom by what it's missing on the other side. So for instance, in this first one, I have t plus 2, t plus 1, okay? I'm going to multiply this one here by t minus 1, okay?
And that one by 2 plus 1.
And then I'm going to do this one by t plus 1, and all my bottoms will be the same then. But whatever I do the bottom, I have to do the top again. So, oops, that's not the color. So, we're going to multiply the bottom by t minus 1, right? And we're still keeping the old ones, t plus 2, t plus 1. Only difference is now I'm doing 2 times t minus 1. I have to make sure I do it to the top also. Does that make sense? Okay. And on the other side, I need to multiply by t plus 1. That's what it's missing. So I have t plus 2, t minus 1, t plus 1. And then I got to do that times the top, t plus 1. So if you look now, I have a t minus 1, t plus 2, and a t plus 1. So now I have common denominators. All the denominators are the same. And I can simplify the tops of my equations, which I'm going to do. And actually, like I said before, once our denominator is the same, I can make it just a question where I deal with the top of the fraction. Okay? So I'm going to put this all over t minus, it's not a minus, there you go, t minus 1, t plus 2, t plus 1, okay? It's all over that because the denominator is the same. This is going to become 2t minus 2, and I multiply like this. Does that make sense?
Mm-hmm.
Okay, so I have 2t minus 2, I'll put that in brackets, subtracted by, and that's just going to say is t plus 1. Okay? Now I just have to simplify the top. It's a negative sign, so I can drop the brackets, but what's going to happen is these will become opposites. So it's going to be minus t minus 1. Does that make sense? And the bottom's still the same. Okay? And then I collect my like terms. So 2t minus t is going to give me just t. Negative 2 minus 1, negative 3. And then on the bottom I have t minus 1, t plus 2, t plus 1. And now since it's all factored out, it's really easy to state my restrictions. My restrictions are, I'm going to have 3 of them. T cannot equal 1 Yeah, -2 and -1. Right? So those are my 3 restrictions. Now, they may want you to expand the bottom, but essentially it's the same answer. If you were to expand it, do you know how to do that? Yeah? Okay. Okay, so the question is asking us to solve for a and b, uh, assuming that a divided by x minus 1 plus b divided by x minus 2 is equal to this equation. Okay, now what we have to do is kind of reverse engineer what we've done. So if you remember, to make our denominators common, our 2 fractions, whatever they were, had to have the same common denominator. So I'm actually going to take that and put it on the bottom of both fractions, and then I'm going to split the top. Okay? So I'm creating semi what they've done here. So I'm going to have one fraction, so that will be pretty much my a fraction, we'll call it, and this will be my b fraction. Okay? But I'm going to put the denominators the same, x plus 1, x minus 2, that's one denominator. And it's an addition sign, right? And they have an addition sign up here too, if you notice, in between. So that works out great. X plus 1, x minus 2. And I'm going to split these. I'm just going to put 2x on one and 3 on the other. Okay? Because essentially this is the next step backwards. The denominators are the same. Now, what we're going to do is we essentially need to get rid of our x minus 2 in one of them and our x plus 1 in the other. Okay? So, do you have any ideas? Okay. Essentially, we split these up. It's supposed to be -1. What you can do is, remember, to get to this point of where we are with our denominators, essentially, we probably started with this as the denominator of one of them, and this is the denominator of the other. Okay? We don't know which for which it was. So what you can say is, if we were reversing it, at some point we would have multiplied the top by the opposite one, right? So say this was the x minus 2 and the x plus 1. The only difference is they ended up with these numbers, and we don't know how they did that. Now technically we would divide, but that gets kind of complicated. So we'll do it the way she did in class. We'll start with her a plus b. So a x minus 1 plus b x minus 2. And it was equal to, well, actually it doesn't really. The denominator is what's important. We have to make sure we know what the denominator is, okay? So what she does is she actually works backwards, okay? She knows that to get the denominators, right now she wants to create her a and b to have the same denominator as the question has. In order to do that, I have to multiply my a by x minus 2 and my b by x minus 1. So in my next line, I'm going to have a multiplied by x minus 2 divided by x minus 1 times x minus 2. Does this make sense?
Mm-hmm.
Plus, and the opposite in this one, x minus 1 times b over x minus 2, x minus 1. Okay? So again, we've created denominators that are the same, so we can combine them again. Okay? So we're both going to have x minus 1, x minus 2, but our tops and bottoms, she foiled this. So she did a times x, oh my gosh, a times -2. So we get ax minus 2a. Does that make sense? And then it's plus b, and when we foil b, oh, excuse me, we do the b times both of them. We get plus bx minus b. Cool. Okay. So we have this here. Technically, we could simplify these two terms here, ax and bx. We could say that we could say a plus b times x. All right, we don't need to write that way. That'll be a little too complicated. Okay, here. So technically, we were doing like terms. This is positive, right? So normally we would add these two together. Our variables are the same. And when we add them together, we'd add the first coefficient and the second coefficient. And we would leave whatever the x is. Well, because we don't know what numbers they are, we only know that a plus b x. Okay? So essentially, I can simplify this a little. If I put this in, say I was going to simplify these two terms, it would be a plus b, whatever those numbers are, times x. So an example of this would be, let's just say the first one was 2x, and the next one over there, our b was 3x, okay? Let's say it was that, and we're adding those two. Essentially, we can turn it into a question like this. 2 plus 3 times x, that gives me 5x. And if you had just done that from the start, you probably would have noticed 2x plus 3x is 5x. But do you understand the idea of putting into brackets? Okay, that's what we've done here because we don't know what the variables are. Okay? So since we've done that, I'm now also left with negative 2a minus b all over x minus 1, x minus 2. Now what's really important here is what she did is she's now related it to the original. I'll rewrite the original. The original was 2x plus 3 over x minus 1, x minus 2. Okay, so if you take a look at this, well, our denominator is the same. We're pretty far. And they have an x here. We have an x here. The coefficient is going to be 2. So I know my a plus b is going to need to add up to 2, whatever the two numbers are. I also know that negative 2a minus b is going to have to become 3. Yeah. So really, I can not worry about what's left in this question. I can make two new equations. Okay? I'll do them in green. We know that a plus b is going to equal 2. And I also know that negative 2a minus b is going to equal 3. Does that make sense, those two little equations? Have you done solving by elimination? Do you remember that grade 9 thing? Solve by elimination? This is kind of like a solve by elimination here. It's set up just like that. If I were to add these equations together, the b's will cancel out. I'd be left with 5 over here. And a plus negative 2a is negative a. Does that make sense? So a is going to be negative 5. And then when I plug negative 5 into an equation, let's say our original one, we call this equation 1 and this equation 2. A plus b equals 2. Well, my a is negative 5 plus b equals 2. If I bring negative 5 to the other side, I get b equals 2 plus 5. B equals 7. Okay? So in this example, our a and b are going to be negative 5 and 7. And what we can do is plug them in just to check. Okay? So let's plug them in. A we said was negative 5, so we have negative 5 plus 7x minus 2 times negative 5 minus 7 all above x minus 2. Okay. Negative 5 plus 7, so 2 times x is 2x. And here we go. Negative 2 times 5.
Negative 10.
Not
And
negative,
then
but 10. And then minus 7.
Just 3.
Yeah, which is going to be 3. So x minus blah, blah, blah. And then finally, we get 2x plus 3 is equal to x minus 1, x minus 2. So what does, in our AB form, rated in red, it was negative 5 over x minus 1. What did the original question ask? Plus? Yeah. Plus 7 over x minus 2. So these two things here are equivalent. Does that make sense? It's a long question, eh? There's quite a bit to that one. Okay, so 6 says, find the simplest expression of the volume of the given prison. Now, a volume is your length times width times depth. Okay? Right now, we don't actually have a measurement for depth. We don't know what it is. There's a possibility that this is a cube, but in order to even get started on that, we're going to have to simplify these two expressions. Okay? So in order to simplify both of them, we're going to factor them. We're going to factor them all and see if we can cancel things out. And then we're going to multiply our two simplified sides together just to find the area of this face here. That's the front face. Oh, cool. Okay, just to find the area of that front face. So let's start with this one. We'll call this number 1 and this number 2. I'll do them in black. Okay, so number 1 says that negative 4x squared plus 9 is equal to 20x squared plus 23x, we think, plus 6, right? Okay. In the first question, do you remember difference of squares?
Yeah.
Okay. In a difference of squares, you have to be able to find the square root of the first term and the last term. Can we do that? Can we find square roots? And it's also called a difference of squares because what? The term in between needs to be, what does difference mean? Negative. Right now it's positive. Okay. In order to make this negative, I'm going to common factor the top. Okay? So when I common factor the top, I'm going to take negative 1 out of both. Because also, I technically can't find the square root of negative 4. There is none. That's another hint. Right? There's no square roots of negative numbers. So when I take negative 1 out, I'll write negative 1 on the outside. I'm left with 4x squared, right? It's now positive, minus 9. Now I have a difference of squares. I can factor that. I also have, is there a common factor in that? In the bottom ones? 23 is prime number, so it can't be a common factor. Okay? So let's factor these two on the outside. So we'll do some red. Difference of squares, I'm going to be left with what?
2x plus 3 and 2x minus 3.
Good. Okay. And of course that negative 1 is going to have to stay on the outside. Okay. Now when we go to factor the bottom here, I'm going to take the factors of the first term and the last term. So you've done this style before. So we have 20 and 1, 2 and 10, 4 and 5. Those are all the factors of 20. Yeah. 1 and 6 and 2 and 3. Now I know I have to multiply. Think of these as columns, each of these. I have to multiply a pair of columns, and their products are going to have to add up to our middle term, which is 23. Okay? So I'm quickly going to trial and error this. 20 times 1, 1 times 6, that's 20 and 6. Is that going to add up and work? No. How about 20 times 6 and 1 times 1? That's going to give me 120 and 1. Oops, I forgot that does that. Is that going to work? No. So we know that combination doesn't work. Let's try 20 and 2 and 1 and 3. 22 is 40 and 1 and 3 is 3. Any combination of 40 and 3 going to work? 20 times 3, 1 times 2. I'm going to get a 60 and 2. Any combination of that going to work? No. So I've done this first column by both of the second ones. So by elimination, I know this column doesn't work. Okay? Now I'll try the next column. 10 and 2. Or sorry, 2 and 1, 10 and 6. That's going to give me 60 and 2. I forgot when I do that. Any combination of that going to work? No. How about 2 and 6, 10 and 1? 10 and 12? No. Okay. Let's go to the next column. 2 and 2, 10 and 3. That's going to be 4 and 30. No, not going to work. How about 2 and 3 and 10 and 2? 6 and 20? No. Okay. By elimination again. I know that column doesn't work. So it's got to be this column here. And it's going to be multiplied by one of these. Let's just figure out which one. 4 times 1 and 5 times 6. That's what? 30 and 4. Is that going to work? 5 and 1, 4 and 6. 4 and 6 is 24. 5. Are they going to work? Okay, we're assuming this column's not going to work. Let's find out. 8 and 15.
Yes.
Hey, there you go. 4 times 2 and 5 times 3. Okay? So we also know this column didn't work. So our answers is our two columns. This column and this column are going to be multiplied. And what's important is you know which one is multiplied by what. So we did 4 times 2, correct? We went this way, and 5 times 3. That gave us our 8 and our 15. The answer is positive 23, so both of these need to be positive, which means these two terms in here are both going to be positive. Now when I go to put it in brackets, this is where a lot of students make mistakes when you're factoring this way.
It's 4x plus 2 and 5x plus 3.
Close. Very, very close. You got to use these numbers from this column. Don't use these ones on the outside.
I have to?
Yeah.
Yes, this
But the only other thing is, we know these are going to be the first term, so I'm just going to plug them in. I know I'm going to have 4x and 5x. Whatever number I multiplied by, so I did 4 times 2, the positive 2, they have to go in opposites. So my 4 goes here, my positive 2 has to go in the other one. Okay? I did 5 times 3, so my 5x and my positive 3 have to go in opposite brackets.
Oh, because when I do that, I cross multiply, so.
So these always have to go in opposite brackets,
Yeah.
okay? So all we did was factor the bottom there. So let's rewrite our question. We know we have negative 1, 2x plus 3, 2x minus 3, correct? And we have 4x plus 3, 5x plus 2. Okay. So now what we've done is we've factored all of this question here. We simplified the first part. Nothing really canceled out, but we got our answer. We're going to factor the second equation, okay? So I'll do that on another page just so we have room. The other equation says negative 10x squared plus 11x plus 6 divided by 2x squared minus 5x minus 12, right? Same idea, we're going to factor these, okay? Same way we've done the other one. So we'll do the top in blue. Factors of the first term. Now remember, this is a negative 10, so this is kind of going to change a little too, okay? What you can do, sometimes make this easier, is you can factor out the negative and then reapply it after if you want. But have you done factoring when the first number is a negative? No? Let's take it out then, okay, just to make it easy. So it's going to be negative 1 on the outside. We'll have 10x squared minus 11x minus 6, okay? Then we're going to factor this. Factors of the first term, 1 and 10, 2 and 5. Factors of this, 1 and 6, 2 and 3. And we know products need to add to negative 11. Okay, so I'm going to look at this. Can you find anything that you think might work quickly?
One and one and no, it's 2 and 6. It's confusing with the 2 long.
Okay, so quickly looking at this, I discovered that this and this will work. And the way it'll work is if I do 2 times 2, I get 4. 5 times 3, I get 15. As long as the 4 is positive and the 15 is negative, I'll get negative 11, okay? So that means the 3 needs to be a negative and the 2 needs to be a positive, okay? So when we go to put it into brackets, I'm going to have my negative 1 out here. I'm going to have 2x and 5x are my first terms. And I got to put them in opposite. So the positive 2 has to go opposite of the 2x, and the negative 3 has to go opposite of the 5x. Okay? So we have 2x minus 3, 5x plus 2. And then let's factor the bottom half of this. 2x squared minus 5x minus 12. Same idea. Factors of the first, factors of the second. Sorry, I had to squeeze this one. Does this make sense how I set it up? Alright, I'll pause this part. Okay, so obviously we're using this one, and we're using 4 and 3 discovered. 4 times 2 is 8. 1 times 3 is 3. If the 8 is negative and the 3 is positive, we'll get negative 5. So that means this 3 has to be positive, this 4 needs to be negative. Does that make sense when I say that?
Mm-hmm.
So our first term, we know one is going to be 1x, or just x. The other one's going to be 2x. And they got to go in opposite columns. So we did 1 times positive 3, so positive 3 goes in here, and negative 4 goes in here. So when we go to rewrite this all, that was the top and the bottom. This was our top. So our top of our equation says x minus 4, 2x plus 3, over negative 2x minus 3, 5x plus 2. Does that make sense? Okay, now I'm going to refer back to what we'd found on our previous page quickly. Our answer on our previous page was this. I'm just going to quickly copy it. Go to our other page, just so we can see some similarities. Actually, you know what? I'll make a new page. Paste this one. I'll go back. Get this answer. Let's just move this over. Okay, so we got them both on the same page. In order to find volume, we actually technically have to multiply them, right? Okay, so I'm going to rewrite them all in red. Volume is going to be, sorry, we only have 2 measurements. So technically this is the area of one of the faces. So our area is equal to negative 1, 2x plus 3, 2x minus 3 over 4x plus 3, 5x plus 2, multiplied by x minus 4, 2x plus 3, negative 2x minus 3, 5x plus 2. That's not a 2. Plus 2, right? Okay. So we take a look at these. Technically, we have to multiply these, okay? Instead of foiling and everything all over again, I'm just going to put all of the brackets beside each other.
Can't you cancel first?
I can. Do you know how to cancel right now?
Yeah.
What's going to cancel?
Can you just cancel? Can anything cancel, or does it have to be cross?
It's going to have to be... What do you mean by cross?
Like, do they have those 2 cancel? Are they? Can they? Because they're...
Which 2? These 2?
Yeah.
Well, they're both on the bottom.
So they can't.
Normally, they'd be multiplied by each other. So they actually create something even larger. They're squared. Okay? What I'm going to do is I'm going to combine them all. Okay? I'm going to get rid of this multiplication sign. Really, this is what it looks like. 2x plus 3. This is what the fraction will look like. Okay? Minus 3. X minus 4. Because this is multiplication. 2x plus 3. And because multiplication, it doesn't matter what order I multiply these in. It's not going to make a difference. So I'm just going to write them in. And technically, it's all above. Again, I'm going to move this to the front, okay? Just so you see that there's a negative 1 there too also. 2x minus 3. 5x plus 2. That was this side. And then I'm going to put this side in.
Can't you just cancel the negative 1?
Okay. So I have a whole bunch of things here. Right now I know negative 1 divided by negative 1 is just going to be 1. So those are going to cancel out, okay? So we'll actually mark them in blue. Those 2 cancel out. Are there any other equations, because this is a fraction, that are the exact same? Top and bottom. You sure?
Yes.
What about 2x minus 3 and 2x minus 3.
Oh, I didn't see that one.
Those are the same. So essentially, I could line them up together, and when you divide 2x minus 3 divided by 2x minus 3, it's just going to be 1 again. So these two cancel out. Okay. Now I look through the bottom and the top. There's nothing else I can really do. But there's something on the bottom. I can rewrite this and this
Square.
as just a square.
And that too, then, right?
And there you go. I can rewrite that and that as a square. So a simplified version, I'll write this in black now, okay? Is going to be, I'm going to put this one first, my x. Oh, that's not supposed to look like a negative.
Are you able to factor again, like FOIL and factor, or is there no point in FOIL?
If you FOIL again, you're just going to end up with these as your factored forms. So there's really no point. So we have x minus 4, and then we have x, 2x plus 3 squared. Okay, so that's pretty simplified compared to before. And we're going to have 4x plus 3 and 5x plus 2 squared. Okay. Now, the only issue with this question is, remember, it says it's a volume question. They'd only give us 2 measurements, so we're only able to find the area. And it wasn't a square, because the two distances and lengths, these two equations were different. So I'm not sure if you were missing something. Did you want me to print the notes that I made here?
Okay.
Are you sure? Did you write any of them down?
No.
I'm going to print them for you, okay? Just because it'll become helpful for you. Meantime. What am I going to print? Oh, whoops.